As you begin to jump into the world of classes and objects, you're going to come across a term and a functionality called a constructor. And so in this video, I want to kind of explain what a constructor is, and then in a separate video, actually write some code, and I think it'll kind of really make it clear to you. All right, but first of all, let's talk about the theory behind a constructor. Now, a constructor is a special function inside a class. Now, let's back up just a minute. In previous videos, we talked about what a class is. A class is simply a blueprint. It's a set of code that we're going to base memory objects on, and then we're going to carry out various program functionalities using that code in a class that is instantiated as an object in memory. Well, whenever we take that class and create a new object, the object has to be constructed in memory. Okay, and so the constructor is what goes through the process, or that starts that process of creating that object in memory. But for our purposes, a constructor allows us to create our objects with specific data as part of that object when it gets initialized. Now, what this does is it saves us a couple of steps in working with the object. It also lets us do some cool things as far as to what specific object gets created. Now, here's the bottom line. A constructor is a function that has the same name as the class. Now, in a previous example, and if you go back and look at defining a class or creating objects, we created a very simple class called cat. And so our cat class had age, name, weight, those kinds of properties. But when we created an object off of that cat class, there was a constructor in there with the same name, and it was a function called cat. Now, we didn't see it and we didn't write it, but it's in there nonetheless. The compiler takes care of that. Well, when we're talking about working with a constructor, we're going to create our own constructor, and we're going to put that function in there with the same name. It won't have any return data type, and here's the big thing: constructors can be overloaded. Now, I'm hitting you with more C++ terms. Actually, they're object-oriented programming terms, and they're not necessarily unique to C++, but they're very much a part of C++. The overloads, if you'll go back, if this is all new to you and you're getting a bit confused, go back and look at the movie entitled Function Overloading, because we're going to do the very same thing to a constructor, and you'll see that we've got a really neat little set of power here that we can use when we're working with our own classes and when we are creating objects off of our own classes. All right, now this is a lot of talking just to explain what a constructor is. Okay, the bottom line is a constructor is a special function that we can put in a class that lets us create an object a number of different ways. So join me in the video entitled Using a Constructor, and we'll build one in code, and you'll see exactly what I'm talking about. Now let's look at actually using a constructor by jumping out into some code and actually coding up some examples. Now, what I've got here is a solution, a project that I named Constructor Example, and I'm working on a class module, or a code module rather, a class CONSTR. You will find this project out in your work files folder just like before, and I've created it all the same way. Okay, this is a Win32 console, empty project. Went in and added my module here. Okay, go back and look at some of the other examples to see how to build these. Now, if you'll remember, in some previous examples we built a class called cat, and so here is that class. All right, just like we finished it back when we were doing the videos on defining a class and so forth. Now, what we're going to do here is take a look at the constructor. Now, you don't see a constructor here right now, okay, but let's build a constructor just to show you what's going on. First of all, if I come down here and I say cat is the type and C1 is the variable or the object, well, then when I call C1 and press period, I see all the various things, right? And what I want to do now is take a look at using a constructor. I don't see one, but let's go back and make one. Okay, and so what I'm going to do here is create a function with no return type that's the same name as my class up here. All right, and so you'll notice cat, and I'm just going to leave this without any parameters, and I'm going to come down here and put this, and then notice what I'm going to do. I'm going to set the name equal to Fluffy. Alright, now this is going to create pretty much a useless class. Okay, so I'm going to come down here and create cat C1 and just bring it into existence, and then I'm going to do a little output here. C1 name equals, and I'll just do C1 dot name. All right. Now all we did is created the class, and then we're just going to output the name of that's in that name property in that class. All right, and so we will compile this, and I can hear some of you yelling at the monitor, what a useless idea, what a useless class. And it is, but it'll show you exactly what's going on. And then I'm going to demonstrate in just a second, believe it or not, how to actually make this useful. Okay, so here's our constructor example. I will hold down my shift key, right click on debug because I am in Windows 7, and I will open the command window here. And now I will call the constructor example, and you'll notice that the name is already Fluffy. Okay, all I did, let me make this go away and drag this down so we can see it. All I did is created an instance of the cat class, and the name is already set to Fluffy. Why? Because I used a constructor. Notice the constructor has the same name as the class. So when I used this class to instantiate an object, one of the first things it did is ran the constructor and said, whatever they've put in code here, let's run this code as this object is created in memory. And so I have ensured here that every object that gets created off the cat class is going to have the name Fluffy. Now obviously out there in the real world that's not going to be the way we want to do it. Okay, but I do want you to think about this. Anytime you have any aspects of a class that when objects are created they always need to have certain functionalities, a constructor is the way to do it. And there's your constructor. Same name as the class, no return data type here. All right. Now that's the simplest example of a constructor you're ever going to find. But let's add a little more to it now. Let's say, better yet, let's pass in a standard string. Okay, and we'll just call it X. And now what we will do is we will set name equal to X. All right. And so you'll notice now we've got this little squiggly down here, and it's saying, hey, wait a minute, there's no default constructor for cat. What it's really telling you is you've got to throw me something here, and notice it's saying throw me a string. All right. And so I'm going to say tiger, just so you can see the difference. And let me get the case correct on all the things here. And so now notice what I'm doing is as I create the class or the object C1 based on cat, I'm passing it a string, and it is going to load that string into name. Now I've got something a little more useful. So let's compile this and run it and look at some of the cool stuff we can do here now. And so I will come back out into the code example, and I will rerun it, and notice now the name is Tiger. Okay, and we can come back and we can call our cat Spot. Weird name for a cat, I know, but we can very easily now, as we create our new objects, give them whatever name we want as they come into being. Okay, so I hope this gives you a little idea of the power of constructors, and in the next video I'm going to show you something even cooler that you can do with constructors, and that is you can overload them. So join me in overloading constructors, and let's take a look at that. Welcome to overloading constructors. Now, in previous videos I talked about what a constructor is, and then demonstrated with some code examples using the constructor with the cat class here. And in this video I want to go a little bit farther, and that is overloading constructors. Now, this is where the real power and design aspects really start to show themselves with object-oriented programming. Now, if you'll remember, in the video entitled Using a Constructor, we used just a basic constructor for the cat class, and I first did just a default constructor, and then I gave it one parameter, and then we could pass it an argument and always name it. Well, let's do a different idea here, and let me put you some notes in here. Now keep in mind, let me point out something. I'm going to use the same example project here. So when you look up constructor example in your work files folder, you're going to see the whole thing, all right? But anyway, first of all, this is a constructor, all right? Now, let's jump down here and let's apply the concept of overloading to this constructor, all right? Because I can create cat again, right? And this time I can do overloading. And if you remember, overloading means a different signature. Okay, so I can do int age, all right, int weight, and then the string name. And now I will set some of the various things. Age equal age, weight equals weight, or in other words, whatever they're passing in when they call this, right? Notice age right here that they pass in is going to be placed in age, which is the variable in my class, all right? And then, of course, name inside here is going to be equal to, and I'm going to go change that to keep from absolutely totally confusing the whole world, is equal to nm, all right? And so I can now overload this, all right? And so now, based on how I call this particular class, it's going to determine which one of these gets used, okay? So now notice I can still call cat, right, and create an object called C1, or instantiate an object called C1 and pass spot in, and that will work because that's going to see, oh, wait a minute, dude's only passing one parameter, all right, and it's a string, and so I've got a constructor with that signature, so I will construct cat using that one thing. Now notice here's age, weight, and string. And so let's go out here and create another instantiation of cat, and we'll call this C2. And this time, notice we now see that there are three. Notice there's our default. There's the one with string, and now here's the one with age, weight, and string. Now notice this is cool. IntelliSense picks this up. I didn't actually have to code this. Looks like I was up all night wiring this stuff up. And so we'll say that the age of this cat is 4. The cat weighs 6 pounds. I don't know if that's heavy or light for a cat, but anyway, and this cat is our beloved Fluffy that we keep talking so much about here, all right? And so I call that, and now I'm going to copy this, all right, and use it so that you don't have to watch me struggle with typing and talking. And we'll just mention here that C2 name is going to be Fluffy that we pass in, right? And then C2 dot mage, we'll put that there, and let's do this. Your example might be a little different from this, but it'll be the same basic thing. And then let's put Fluffy's weight, okay? And we'll put, let's see, W-E-I-G-H-T. The hardest part of my job here is typing and talking at the same time, okay? And we'll call M weight. And this should do it for us, all right? And so now let's compile this up, and you'll notice that we're going to create two separate objects, but each separate object is going to use a different constructor, and that is not what we want. I need to go out here, go into Documents, go into Visual Studio 2010, into Projects, into Constructor. Notice I'm right-clicking on Debug because that's where my actual executable file was created. And now let's just call Constructor example. And notice I've got two things. We've got C1, the name is Spot. C2, the name is Fluffy. The age is 4. The weight is 6. All right. And I've got some pretty hideous formatting issues here. And so let me create a little bit cleaner output here. Now, I hope you get the idea of what you can do with constructors now, because we can overload constructors as many different ways as we can come up with different signatures on these things, okay? And so really, based on what you pass in, you can provide different functionality in your code. Now all this happens when the object is instantiated, and so it saves you the extra step of having to go in and set all that junk, okay? Junk being a Southern technical term for other state data, all right? So anyway, that's just a good simple example of constructor overloading. Stick that in your coder's toolkit, if you will, and use that. It will really help you with structure and design of your programs in C++. Now, as you delve into the world of C++, you're going to come across a term and a concept called a destructor. And in this video, I want to introduce you to the concept. Then I want to show you the reasons you would need one, and give you a little memory lesson on the underlying reasons of why all this is an issue, okay? And then I'm going to encourage you to go do some more research on your own, okay? But the simple answer to what is a destructor is a destructor simply reclaims memory for us. Now, it reclaims a certain type of memory, which is called dynamic memory. And another way to say that is it reclaims memory that has been placed on the heap. Talk more about that in just a second. The way to understand this is just with a simple memory lesson, okay? If in my program I create an integer called I, a variable called I, it's a data type integer, and I initialize it with a value of 4. Well, C++ is going to place this variable I and this value 4 on one of its two places where it manages memory. One of these is called the stack and one is called the heap. Now the stack is a bit of memory that is set aside for use by the programs. All right, it has a finite amount, and if you run out of it, you're in trouble. Okay, you get a memory error and you've got to do something different. If you put it on the heap, however, the heap is all the memory that's available to your computer. Now this is your RAM, your available RAM, any virtual memory that your computer creates with paging out to the hard drive and all that. And so this can be gigabytes and gigabytes of memory, okay? But everything comes at a cost in this life, and so let's talk about what happens. So when we create this integer called I and we set it equal to 4, C++ goes out and creates it on the stack. Everybody's happy. Then when we go out of the function that used the integer I and created it, it does something that we call going out of scope. And this just gets erased off of the stack, and that memory is now available for something else. All of it happens automatically. We don't have to worry about it. Okay, life is good. However, if we create any object and we use the new keyword here, notice here we've created a pointer of type integer, and then we have set that pointer equal to a new instance of integer. All right, what we just done is we created the pointer, and then with the new keyword we placed that pointer out on the heap. Now, if we run our program and we go out of scope for the section of code or the function where all this was done right here, keep in mind this new keyword told C++, put this out on the heap. I want this out on the heap and put a reference to it out there, and I'm going to manage it there. Well, this will never go out of scope. It may go out of scope and I can't get back to it, but guess what? It will never drop off the heap until I terminate the program. Okay? And so this is what's called a memory leak. Because as I use the program longer and longer and longer, I notice that more and more of my memory is getting consumed. And the reason is there's all these objects out there on the heap that I never called the destructor on, and so C++ never went to the heap and took these back off. And so I'm noticing that as more and more objects get created and placed on the heap, and then more and more objects get created and placed on the heap, and they're never deleted, I have less and less available memory on my computer. Now again, this is not the big, huge, hairy deal that it used to be, because now we have gigabytes and gigabytes of RAM available on our computer, but still it can become very problematic. So what's the answer here is that I need to delete this pointer. And I need to just call the command delete pointer, delete PTR, in my code to make that happen. All right? Now, here's what I want you to do. I want you to just understand what a destructor is, and I want you to understand why you need one. And you really should have a red flag go off in your little programmer brain when you use the new keyword, because you should be telling yourself, hey, wait a minute now, I am placing this little bit of information out on the heap, and when I'm done with it, I need to destruct it. Okay, I need to call a destructor and get that off the heap, or I'm going to basically consuming memory that I can't really use or get to anymore. Okay, so that's what a destructor is. The memory lesson tells you why you need it. Now, what I would strongly suggest that you do, and I'm not going to do an example here because of a time constraint, and also don't want to wander into a world that just keeps getting deeper and deeper here. I want to kind of keep this on this introductory level. But the main thing you need to understand here is what a destructor is, why you need it, and then just go out there and kind of dig around, look at some examples of destructors, and based on where you are along the timeline of comfort level with C++, you can go a little deeper and look at some more advanced examples of this. But the bottom line is, if you're using that new keyword to bring your objects into existence, you're placing them on the heap, and when you're through with those objects, you need to call delete to take those objects off the heap and clear their memory out and make it available for something else.